Welcome back to the deep dive. This is where we take those huge waves of information and really distill them down into something clear, something useful for you.
And today, we've got some seriously big news.
Oh, yeah. Probably the biggest shakeup, I'd say, in the open source hardware world in maybe a decade.
Easily.
Yeah.
We're talking about Arduino,
Yeah.
the heart of so many maker projects.
That little Italian board, yeah. Well, they've just joined forces with Qualcomm, the chip giant.
It's huge. More than just joining forces, it's an acquisition. Announced October 7th, 2025. We don't know the exact amount, but, well, it changes things.
It really does. It kind of redefines where you start with robotics, with IoT.
Yeah, the whole learning curve. It's different now.
And they didn't wait long for the wedding gift, did they?
No. Straight away, we get the Arduino UNO Q.
Which looks like the classic UNO, that familiar shape. But inside, it's a mini computer.
Seriously powerful. AI, Linux, all packed in there. It's kind of mind-blowing.
It looks like that $20 board maybe you started with, but it can run incredibly complex stuff now.
So our mission today, for you listening, is pretty clear. We need to cut through all the tech specs, all the jargon.
Right. We want to understand why. Why did Qualcomm do this?
Exactly. And then really tour this new UNO Q, figure out its superpowers, as you might say.
And think about what it means for the open source world, for the maker community. It's a big shift.
Definitely. So maybe let's start with a little context. Arduino's history.
Good idea. Because many people will remember it started back in, 2005? In Italy, Ivrea.
Yeah, and the whole idea was simplicity. Make prototyping affordable, especially for students.
And it just exploded, created that first huge wave of makers.
It really did. It dominated because it was easy to use and the community was massive, very welcoming.
But things change, right, the last few years?
Yeah, the market got tougher, more competition. Things like the ESP32, Raspberry Pi.
Yeah.
They offered more power, more connectivity.
So Arduino had the community, the ease of use, but maybe not the raw horsepower for some of the newer projects.
Pretty much. They were falling behind a bit on the performance side.
And Qualcomm, well, they definitely have the horsepower. So why does a giant company focused on mobile chips buy a, 20-year-old open source project?
It's all about the market. The next big thing isn't just phones. It's everything else. IoT, robotics.
Okay.
And that market is said to be enormous. McKinsey reports are saying, what, $1.1 trillion by 2030?
Wow, 1.1 trillion. That's bigger than the entire semiconductor equipment market right now.
Exactly. It's a massive prize. And Arduino. It's the shortcut.
How so?
They didn't just buy tech. They bought a community, a direct line to 30 million users worldwide.
Hobbyists, students, engineers, the people already building the prototypes for that trillion-dollar market.
Precisely. It's an instant customer base, an instant developer community.
Yeah.
Highly engaged, already using the platform. It's brilliant, really.
Okay, but let's get into the business side. Because whenever a big corporation buys a smaller, community-focused company, people get nervous.
Understandably. Is this a partnership, or is Qualcomm going to sort of absorb Arduino and maybe close things off?
Yeah, that's the fear.
Well, the initial messaging seems very focused on calming those fears. They're saying Arduino will operate independently under Qualcomm technologies.
And they're specifically saying they'll keep the open source core, the community focus.
That's the official line, yes.
Yeah.
Explicitly preserving the ethos.
I saw that quote from Massimo Benzi, one of the co-founders. He was stressing it's about getting more resources.
Right. More fuel for education, for higher-level prototyping, but keeping that DIY spirit.
It sounds like they needed Qualcomm's muscle, financially and technically, to keep up in the hardware race.
I think that's a big part of it. And their joint goal makes sense in that context. Democratizing AI at the edge.
Okay, AI at the edge. What does that mean in simple terms?
It means doing the smart stuff, the AI processing, right on the device itself, not sending data up to the cloud and back.
Ah, okay. Faster, more private sometimes.
Exactly. And they've set a huge target, empowering 10 million more makers by 2030.
10 million. That's ambitious. Which brings us back to the hardware needed for that, the UNO Q.
Yep, the star of the show.
Now, the original UNO was famous for being cheap, under $30 usually. This new one, the UNO Q, is $44. That's a jump. Is it still really accessible in the way Arduino always was, or is it becoming more of a pro tool?
That's the $1 million, well, the $44 question, isn't it?
Yeah.
It definitely pushes the boundary of Arduino's traditional affordability, especially for students or hobbyists in some parts of the world.
Yeah, once you add shipping, maybe tariffs.
Exactly. But
Yeah.
you have to look at what you get for that $44. It's not just an Arduino anymore. It's a full single-board computer in SBC.
Like a Raspberry Pi, but in the UNO shape?
Sort of, yeah. But with some key differences. It's powerful enough to compete with systems that cost way more. They're positioning it as that bridge, the affordable way to get into professional-level AI and IoT work.
Okay, let's break down the hardware then. You called it the double brain approach. That sounds important.
It is. It's key to understanding why this board is different and maybe why it costs $44. It literally has two processors working together.
Two brains. Okay, what's the first one?
The primary brain. That's the Qualcomm Dragonwing QRB2210. This is the powerhouse.
Specs.
It's a quad-core ARM Cortex A53. Runs up to 1.5 gigahertz. Plus, it has an Arduino 702 GPU for graphics.
Okay, quad-core, 1.5 gigahertz on an Arduino board. What does that let you do?
It lets you run Linux properly. It supports Debian Linux right out of the box.
Whoa, okay, so it's not just running simple Arduino sketches anymore.
Not at all. This thing is a computer. You can run complex Python scripts. You can host a web server on it. You can run series AI models like large language models directly on the board.
That's the game changer for Edge AI then.
Absolutely. That's the enabler. But there's a catch with using just a powerful Linux chip for controlling things in the real world.
Right, like motors or sensors. Linux isn't always fast enough for instant reactions, is it? It has overhead.
Exactly. Linux is great for complex thinking, for running big applications, but not for those split-second guaranteed timing things you need in robotics or control systems. That's where the second brain comes in.
Okay, the secondary brain. What is it?
It's a dedicated microcontroller. An STM32U585, which uses a Cortex M33 core.
And its job is?
Real-time control. It runs a real-time operating system, Zephyr RTOS. Think of it like the reflexes.
Give me an analogy.
Okay, imagine the Qualcomm chip running Linux is the conscious brain. It sees the ball, decides I need to move towards it, runs the AI vision model.
Right, the high-level plan.
But the STM32 chip, the secondary brain, is like the spinal cord. It handles the immediate critical tasks, reading sensors precisely, synchronizing motors perfectly, hitting the emergency stop instantly.
Even if the main Linux brain is busy doing something else.
Precisely. It guarantees that real-time performance you absolutely need for things that move or react quickly. You need both, the thinker and the reactor.
That makes a lot of sense. One for the heavy lifting, one for the fast footwork.
You got it.
And the connections on this board are pretty serious, too. It's not just the basic pins anymore.
No way. They've packed it in. You get Wi-Fi 6, Bluetooth 5.2.
Okay, latest standards.
Gigabit Ethernet. Not just standard Ethernet, but gigabit. USB 3.0. And, get this, HDMI video output.
HDMI, on an Arduino.
Yep, that changes things. You can connect a proper camera for high-res computer vision, stream video, even build interfaces directly on a monitor connected to the Arduino.
Wow. And storage. AI models can be big.
Good point. It keeps the standard GPIO pins, so old shields might still work, but it adds an eMMC slot. You can put in up to 128 gigabytes of storage.
Okay, that's plenty for complex models and data. This thing is, it's seriously spec'd out.
It's a beast, especially for the size and, relatively speaking, the price.
So let's talk AI. That's the core reason Qualcomm's involved, right? How do you actually do AI on this thing?
So the key is Qualcomm's own software tools. Their neural processing SDK.
Okay.
It's specifically designed to run machine learning tasks, like recognizing objects in video or analyzing sensor data very efficiently on their chips. Low power consumption is a big focus.
And doing it on the board, the edge computing thing, why is that better than just using the cloud?
Two main reasons: speed and sustainability, or latency and power.
Yeah, explain.
Well, speed first. Sending data to the cloud, waiting for processing, getting the result back, that takes time. Milliseconds, but critical milliseconds.
Right, if it's a self-driving car or a fast robot.
Exactly. Studies show Edge AI, doing it on the chip, can cut that delay, that latency, by like 70%. That's huge.
Okay, speed makes sense. What about sustainability?
Think about the energy used sending data back and forth constantly. Billions of IoT devices all talking to data centers. It adds up.
Yeah.
Doing the processing locally saves a lot of that communication energy. It's much more power efficient, which is vital if you want billions of these devices running without draining the grid or needing huge batteries.
Makes sense. But isn't developing for this going to be incredibly complicated? You've got the Arduino sketch world, the Linux world, the AI tools. It's like juggling 3 different things.
That was a massive hurdle. You'd be bouncing between different software, different programming languages, a real pain. But they seem to have tackled that head on with the new software. a unified Arduino IDE.
Unified.
It
Aha.
supposedly brings it all together. You can write your traditional Arduino C++ code, your sketch, for the real-time chip.
Okay.
And in the same environment, you can write and run Python code on the Linux side and integrate the AI models using Qualcomm's tools, all in one place.
So like one cockpit to fly the whole thing.
That's the idea. If
Huh.
they've pulled it off, it could genuinely bridge that gap, make it manageable to go from a simple blinking light to a complex AI robot.
That really could unlock a lot of potential, thinking about universities, research labs.
Oh, hugely. Places like MIT already use Arduino heavily. Imagine giving them this kind of power in the same familiar package.
You could do some wild projects.
Think about like a student project where you just tell the board, using an LLM running on the board, make a robot that can sort these objects by color and then do a little dance.
Whoa, instead of coding every step.
The LLM could potentially generate a chunk of the control code. The complexity of what you can build skyrockets, even if the how is becoming hopefully more accessible through these tools.
Okay, this all sounds incredibly exciting, but let's be real. There have to be downsides, or at least concerns. The community reaction hasn't been all positive, has it?
No, definitely not.
Enough.
It's mixed. You see excitement, for sure, but also a lot of caution.
Like what?
The classic fear.
Hmm.
Big corporation buys beloved open source project. Will they corporatize it? Will profit motives eventually overshadow the community spirit?
Will things suddenly become proprietary or expensive?
Exactly. You see those discussions on forums, people like Jeff Geerling raising valid points about long-term control and direction. It's a wait-and-see situation.
And that ties into another challenge, right? The learning curve we mentioned.
Oh, yeah. We
Yeah,
said
yep.
scooter to Formula One. Even with a unified IDE, going from blinking an LED to managing Linux, AI models, and a real-time OS.
It's a massive jump.
Huge. It absolutely requires Arduino and Qualcomm to invest heavily in new tutorials, documentation, support.
Otherwise,
Otherwise, this amazing board might just become a tool for professionals and experienced engineers and kind of leave behind the students and beginners Arduino was originally for. They need the driving school, too.
that's a really good point. And what about getting this board out there globally?
Another big hurdle, accessibility. If this is truly about democratizing AI, it needs to be affordable everywhere. Not just the 4044 list price, but the final landed cost.
In places like Latin America, Africa, Asia.
Right. Can they get it there without crazy import taxes or shipping costs doubling the price? That will determine if it's a truly global tool or just stays in richer markets. Supply chains are tough.
And then there's trust, privacy.
Edge computing helps keep data local, which is good.
Mm.
But Qualcomm now controls the core chips, the low-level firmware, the updates.
So the community needs assurance that there aren't hidden backdoors or data collection they didn't agree to.
Vigilance is needed. Transparency about updates, about the underlying system software. Trust has to be maintained.
Okay, and one last challenge, maybe the biggest long-term one.
Sustainability has to be.
These are powerful chips. Even if they're efficient for AI, they still use more power than a simple old Arduino, and making them creates e-waste.
Exactly. We're talking about potentially 10 million new users getting these powerful boards. The maker community often tries to be resourceful, reuse things.
But if everyone's buying powerful new boards every couple of years,
The environmental footprint could become significant. There was that big paper in Nature recently about the urgency of tackling e-waste. This adds another layer to that problem.
so wrapping up, how do we see this overall? Good, bad, complicated?
I think ultimately it's potentially a huge win for the user. You get access to incredible power at a relatively low price point.
Qualcomm gets its community, its path into the IoT market. Arduino gets the resources to scale and compete.
It looks like a win-win-win on paper. If the original UNO was like a reliable bicycle,
Simple, got you there.
the UNO Q is like a high-tech electric bike with turbo boost. It gets you much further, much faster.
It bridges that gap between just tinkering and building really professional, advanced projects. The power is there.
It is. But like you said, with great power,
Dog comes great responsibility.
especially environmentally.
That's the final thought, isn't it? If the goal is 10 million more makers using these powerful systems, how does the whole ecosystem, Qualcomm, Arduino, the community, make sure this growth doesn't just create a mountain of e-waste?
How do we innovate and stay sustainable? That's the challenge this partnership really needs to solve in the long run.
Absolutely. It's something for all of you playing with the UNO Q to think about, too. What can you build, and how can you build it responsibly?
A provocative thought to leave you with. We're excited to see what comes next. Until next time, on The Deep Dive.